This video is about local maxima and minima of polynomials. Recall that a local maximum occurs with the word local means that it's within a certain area of x values, and within some designated area a point might be the highest point on a graph, perhaps of a polynomial, and so that highest point would be a local maximum. Of course, the maximum is the y-coordinate of the point. We found that even on a calculator, which can find local maxima. And a local minimum would be, of course, similar, but now the smallest or lowest point within a certain span. So again, you have to kind of define where you're looking for these. They're not true globally everywhere the graph is defined, but only within a certain place. So within a certain set of x values, some value might be the lowest, and of course the y value of that point is what would be the minimum of the function in that certain interval. Additionally, let's consider one interesting fact. So if p of x is a polynomial, just defined generally as any polynomial, then let's also assume that the degree is n. Okay, then the graph of p has at most, that's a key phrase here, at most n minus 1 local extrema. Extrema that's the plural word for extreme or extremum. This could include a max or a min. The total of local maxima or minima that a polynomial might have of degree n would be n minus 1. You can't have a degree 3 polynomial with 5 different mins and maxes. You're going to be limited to n minus 1 as the most. Now this can help when we were discussing in the past n behavior. We drew pictures of graphs that have, for example, let's take the case of n behavior that goes up to the left and up to the right. Then we said in between the n behavior you have a variation of maybe wiggling the graph might do, but that wiggling might produce local mins at the bottoms of a valley of a graph or a local max at the top of a graph. We now know that that wiggling, though it can vary, is limited by this definition here. If the degree is n, you can have at most n minus 1 local mins and maxes total. This will simply help us in analyzing when we graph functions or look at graphs of them that we're looking at the right thing. We better not have too many local extrema in line with this definition.